So good morning everyone and welcome back to PPS Theory Sessions. We are running through the topic of structures in C language, right? And we have seen number of examples, and just in a previous session we completed structure. Let's quickly go through the topics that we have covered in previous session. Structure with function and structure and pointers. And then, as I told you previously, we'll have a look at union also, and we'll have a look at few programs today. Fine. So that will be our today's content. So we'll quickly revise structure and function. Look, you can pass structure as a parameter to the function just like other variables and array. You can also pass structure member if you want, just like other variable. So inside a function parameter list, you can pass entire structure variable, or you can pass just a member of your structure using dot operator maybe. So that's how we pass. Even we have looked at how we can return a structure from function by just defining return statement and the return type of the function. Okay. So that's the structure and function. And then we looked at structure and pointers. A pointer variable can store address of a structure. Now, if structure variable is normal variable, you should go for ampersand sign address operator. And if structure variable is array, then just use array name to have the initial address of that memory location. But you have to remember that whenever you work with pointer to a structure, members will be accessed using arrow operator. Instead of dot, you need to use arrow operator. And still, if you want to use dot operator, okay, then you can go for star notation, star and pointer, but make sure that you enclose star and pointer variable inside parenthesis, okay, because dot operator has higher precedence than address resolution operator star, okay, dereferencing operator star. So either you may go for arrow operator, or you can still use star with parenthesis and then dot. So if we look at the program that we have covered yesterday, let's have a look at that program once. So we started with one structure, a book structure. So struct book, which consists of title, author, these two are character array, then pages, integers, and price, float. And we have declared, or we have defined this structure as a global one. So you can use this structure anywhere within your program, in any place. Okay. Just a minute, guys. Yeah, sorry for keep you waiting. Okay, let's continue. So we have four members in a book structure, and this book structure we have defined as a global, so that we can use this structure anywhere within the program. So we want to use it here as a return type. We want to use it because we want to declare a local variable. We want to use it as a parameter variable also, and so on. That's why we have made it global. So once we have that structure defined, we can have a variable here. And once we have a variable, we can print the members if we have assigned some value. So all those were the basics, but what we have seen yesterday was how we can pass a structure variable in function. So B1 is a structure variable, and we pass this B1 as a parameter to display book function. So display book function receives that structure variable, and we print all those data. So that was the first example where we pass structure variable as a parameter. Then second example we have seen where we actually return from the function, we return a structure variable and we define a return type. Okay, so if you return that variable, then you need to have a variable on the left side of this function call to catch that value. So we catch that returned value in B1 and then we display B1. So how to pass, how to return. And the third example we looked at was how we can pass the address of our structure variable. So we have used ampersand sign, ampersand B1. So we pass the address of our structure. Now if we pass the address, we use pointer variable on the other hand. And if we do have a pointer variable, then we need to use arrow operators to access all the members, right? So that's the example of structure and pointers. So that's what we have seen till now. And that actually completes our unit also. So we have seen basics of structure, structure members, accessing, nesting of structures, and then we have seen structure with arrays, functions, and pointers, right? So that completes your topics given into the syllabus by university. But as we talked earlier, let us have a look at union also. Because C programming language does have a support of union data structure. It is much similar to the structure. It is still collection of elements of either same or different data types, which you can access using a common name. And just like structure, you can define union also with the use of union keyword. Okay. The difference between structure and union is the size that they occupy, right? So let us focus on this thing now, and let me give you that example. If you have a structure, let's say struct student, and then inside that, let's say you have two members. One is integer roll number and another one is character name of maybe 20, and done. Okay, so this is your structure. Now on the other hand, if you want to store either of these, either roll number or name, you don't want to have both, in that case you can have a union student. Now I know that this is not the best example to consider, but let's understand it with this example. Integer roll and character name of 20. Okay, so either you can have a structure or you can have a union based on your requirement. If you want both roll number and name, then you should go with structure. But if you want either of this, either roll number or name, then you should go with union. Now why? So let's understand this thing. Size of, let's say you have variable s1 here, then if you do size of s1, then it's going to give you integer roll number, roll number will have 2 bytes, right? And just have, let's say roll number will have 2 bytes and name will require 20 bytes because it is a 20 character array. One character requires 1 byte, right? So this is going to be the total of all the members. So it will be 22 bytes size of a structure. But if you have this u1 variable here, and if you do this size of u1, okay, then it is not going to make a total. It's not going to make total like structure. Look here, integer requires, or maybe roll number requires 2 bytes and name requires 20 bytes. Then it is going to acquire only 20 bytes because it is going to find maximum of these two. It's not going to make total. It is just going to find max of any member. Maximum size of any member will be the size of union. Now this you have to remember. Size of the structure will be equivalent to the total of all the members, whereas size of union is going to be equal to the maximum member size. Okay, roll number requires 2 bytes, name requires 20 bytes, so maximum is 20, union size will be 20 here. And this indicates if you have enough size to store both, which means structure can have both these values at the same time. Simultaneously, you can have roll number as well as name stored inside your structure. But if you do not have enough size to store both the values, if you just have enough size to store the maximum largest element, then it says that it indicates at a time either you can store roll number inside this memory or you can store name inside this memory. So at a time you can store either of these members. दोनों में से कोई एक ही स्टोर कर पाओगे, दोनों एक साथ नहीं रहेंगे. And it also optimizes the memory size. So if there is some kind of requirement where you need to have only one value from defined members, then you should go for union. And if there is any kind of requirement which says you need to have all the members, then you should go for structure. It's kind of checkbox and radio button, right? Checkbox allows you to have multiple values at the same time. On the other hand, radio button allows you to select only one option. Okay, so if you have multiple options to be selected, go for structure. If you have only one option to be selected, go for union. Okay, so that's the difference between structure and a union. Now Shubham is asking, if I only use integer roll, then what will happen to other 18 bytes? Yeah, those 18 bytes will be blank. Okay, in terms of union, when you store roll number inside that, so if it requires 2 bytes, then other 18 bytes will be simply empty. And when you store name inside the union, it is going to use all 20 bytes, but it will not store roll number inside. Okay, so that's the difference between structure and union. So we have seen this union can handle only one member at a time. You cannot store all the members at a time. Yeah, Abhishek is asking, can we store both the values in union? You can store both the values, but not simultaneously. At one point of time, either you can have roll number or you can have name. आप उसी के अंदर रोल नंबर स्टोर कर पाओगे अगर रोल नंबर असाइन करोगे, लेकिन जैसे ही आप नेम स्टोर करने जाओगे तो रोल नंबर ओवरराइट हो जाएगा, उसकी वैल्यू नहीं मिलेगी. We'll see that in example also with program. Okay, So what is the syntax? We have already seen that. Make use of union keyword and then your union name. The rest of the structure or the syntax is same like structure. And you can have any number of variables also. So what are the major differences between structure and union? And then later on we'll see the program of structure and union both. So the difference between structure and union, here we use struct keyword, whereas here we use union keyword. Different keywords are there to define structure or union. Now in terms of structure, each member has its own separate storage space. हर एक member को उनकी खुद की memory मिलेगी to store the value. Whereas in terms of union, members will share a common storage space. Common storage space. So it is something like, look, when you have structure, okay, let me show you that. When you have structure, it is going to allocate you total 22 bytes here. Okay, this is going to be total of 22 bytes. Now inside that you are going to have a separation of 2 bytes for roll number and then 20 bytes for name. Okay, so here you are going to have roll number and here you are going to have name. So both these members will have separate memory allocation. But in terms of union, what will happen is you are going to have a memory block allocated to you, which will be of total 20 bytes size. And inside that there won't be any separation. You are going to store roll number as well as name in the same block. So अगर roll number सेव किया तो नेम ओवरराइट हो जाएगा एंड अगर आपने नेम सेव किया यहाँ पे तो रोल नंबर ओवरराइट हो जाएगा बिकॉज बोथ आर एक्सेसिंग द सेम मेमोरी allocation. Okay, so that's the difference between structure and union, memory allocation. Okay, so let's get back to the differences. So that's the second difference. Then all members can be accessed anytime in a structure, but if you have a union, you can access any one member at a time because you can store only one value inside. Total required size for structure will be the addition of memory occupied, total of memory of all the members. Whereas in terms of union, the total required size will be the largest one from the member. Largest one from the member. That is going to be the total size of union. Then the example, struct student and union student. So here as you can see, roll number requires 2 bytes, name requires 20 bytes, 20 bytes array, city requires more 20 bytes, 20 bytes array, and float weight. So float requires 4 bytes. So it's gonna be 46 bytes total. But with the same number of members and same data type of members, union will actually find the maximum of these 4 members, which is 20 byte. So the size of union will be 20 bytes, not 46. And this thing we are talking about 32-bit operating system, integer has 2 byte size and so on. Okay, if you go for 64-bit operating system, then integer size will differ. Look, character will always require 1 byte, whether it is 32-bit OS or 64-bit OS. Character universally requires 1 byte. Okay, so we'll see that in program also. So that's the example of structure in union. And by looking at this size calculation, you can say that structure requires more memory, whereas union requires less memory compared to structure. Memory comparison. Fine. So these are the few differences between structure and union. So what we have gone through is, although we have already gone through the basics of structure, we have also covered union here. And that completes our 8th unit of the syllabus entirely. So let's go through the program for a union and have a look at what is the size of union and what if we try to access all the members of union at a time, right? So we'll jump to the programming environment and we'll write one code for union here. Now this is not a structure example, this is union example, okay? Yeah, before we start that, Shubham is asking, if question is asked in the exam about integer size, which size should we prefer? Where in your written exam, if any question is coming related to size, then you always go for 32-bit reference, okay? 32-bit OS reference. Your integer will be of 2 byte. Fine? Okay. So let's have an example of union here. Let me define a union globally. So we'll go for union keyword. Then let's have student. And inside that, let us go for integer roll number and let's say a character name of 20 elements. And let us have U1 variable for union here. Now we also want to have a look at difference of structure and union. So let's define structure also. Struct student, and inside that also we can have integer roll number and a character name of 20, and this is going to be, let's say, S1. Okay, so we have defined one union and one structure. Now remember, a roll number and name, these two are not a variable. Let me repeat, these two are not variables, these two are members of a structure or a union. And that's the reason you can have roll and name inside structure as well as you can have roll and name inside union also. The same identifier we have used. अगर आप इन दोनों को एज अ वेरिएबल डिक्लेयर करते सेपरेटली तो आप दूसरी बार वेरिएबल डिक्लेयर नहीं कर पाते, राइट? वी कैन नॉट हैव two variables having same name. I cannot have integer roll then character name of 20. Then again if I go for integer roll, then at the time of compilation this is going to give me error because you have already declared one variable called roll. So आप दूसरी बार उसको declare नहीं कर पाओगे. So this is not possible. But if it is a member, then you can do that thing. Okay. So coming back to example, this roll and name is a member of union student, and we have declared variable also, a global variable. When we allocate or when we declare a variable, then we'll have memory. अगर आप ये variable declare करते हो, only in that case you will be allocated memory, otherwise आपको memory नहीं मिलेगी. So we have U1 union student and we have S1 structure student. These two variables we already have. So the first difference, let's find it out, the size. Okay, so let me go for a printf statement, structure size, and let us print the size here. Now I'm going to print that size using size of operator, size of, and I'll pass s1 variable here. Okay, size of s1, and similarly I want to have a look at size of u1, so that's going to be union size. Okay, now look, I'm writing this extra /n just to have a space in the output. It is not necessary that you should write this /n multiple times at the end of your program. आपको ये लिखने की ज़रूरत नहीं है. Okay, this is not something which is required. Yep. So size of operator will give me the size of S1. S1 is the structure, and the other one is U1. U1 is union. Now when we print these values, we need to have some kind of placeholder here. We have seen multiple placeholders here. %D, %S, %F, %C, right? D is for integer, F is for float, S is for string, C is for character, and so on. So I can go for D here, %D, because I know that size of anything will be going to be some integer value. So I can use D here, but if I run this program, I'm going to have some kind of warning at this place. Okay, now there are few warnings, because when size of operator we apply, okay, when we apply size of operator, as you can see, there are a few warnings on size of, and it says that instead of %D, you should use %LU. LU, U is for unsigned integer data type, and LU supports long unsigned also, unsigned long data type also. So long is one more data type. We have seen that in earlier units. Okay, so that's one thing. And then we do have few errors, because we have defined struct as a union student, and we also have defined structure student. Just like integer roll, if I define it 2 times, then it is going to give me error. Similarly here we have student structure and student union, so need to define a different name here. So let me define student U and student S. Okay, so one is union and another one is structured, and then will not have any kind of error. I'm also going to change this to LU, unsigned long, because size will always going to be the positive value, so we may go for unsigned, and sizes may be sometimes a large value, so we go for long. That's what the warning says. Okay, so now if I save this code, and let me clear this output window, and then let's run this. So we have 2 values here. Structure size is 24 and union size is 20. Let's have few lessons. Okay, so now you can see structure size is 24, union size is 20. So the size of structure and union, regardless of having same members inside, it differs. Now character requires 1 byte, so the maximum size of the member here is 20 bytes, and that is the 20 bytes, and that is the size of your union, which is 20 here. But when you go for structure, then name requires 20 bytes and roll number requires 4 bytes here because I'm running 64-bit OS and JCC compiler natively. So 20 plus 4, so total 24 bytes is the size of your structure. Okay. So that's the difference in size. Now, if I store, let's say we have structure, so S1 dot roll number equals to, let's say, 12, and S1 dot, yeah, I cannot assign name by just having name equals to, and this is, by this way we cannot assign string later part in the program. If you declare your character array, then at the time of declaration you can assign strings using double quote, but you can never assign these string like this way. Well, in that case you need to use strcpy function. Okay, strcpy function, and to use that maybe you need to use hash include string.h file. Okay, so what we do here is we make use of strcpy and we pass s1 dot name, and this is my string, right? So need to copy the string inside the name. Now just like this way I can also copy roll number in union u1.roll and name inside the union u1.name, right? So now what we have done is we have assigned roll number and name both in structure and a union. Now after that, let's try to print those things. So I'm going to print it now. This is my structure. Roll number %d /n, name %s. Okay. So first we need to have structure s1 dot roll, and second one we need to have s1 dot name. So that's going to be my structure. And the next one, union, roll number %d, name %s, variable is going to be u1.roll and u1.name. Okay, so what I'm doing here, I have a structure s1 variable and union u1 variable. So I want to store roll number and name both inside structure and inside union. So हमने दोनों structure और union के अंदर डाल दिए. Now let's try to print. Let us try to print structure data and union data both and see what values we have. Okay, so I'm going to run this code now. So size of structure is 24, size of union is 20. That's perfect. Then we have assigned roll number 12 in structure and name Marwari in structure. Now structure can hold both the values at a time. So inside your structure you have roll number 12 correctly maintained and the name Marwari correctly maintained. So you don't have any problem there. Both the values are stored at a time. Then what we have done, we have assigned 12 inside union roll number, and after that we have assigned Marwari as a name inside the union. So this string name is actually going to overwrite your roll number because both these members are going to share the common memory. So common memory location में आपने पहले 12 डाला और उसी जगह पे उसको ओवरराइट करके आपने मारवाड़ी डाल दिया. So then when we access these values roll number and name, तो हमें roll number correct नहीं मिलेगा, right? We do not have the correct roll number here, but we have string name correct here. Name is correct, roll number is not a correct value, right? And that's how we can define that. Okay, whatever is the last value stored in the union is going to be preserved inside the union. All the previous values are going to be overwritten, right? So that's the example of working with unions. Now very rarely you are going to find the usage of union. Maybe in very less number of cases will be there where you will find the application of union. The application will be something like whenever you want to store a single value inside the memory, okay, then you are going to use union. And you need to be sure and you need to be aware which value you have stored inside the union. क्योंकि नेम स्टोर करके आप रोल नंबर एक्सेस करने जाओगे देन इट इज जस्ट अ मेमोरी एक्सेस. कुछ ना कुछ तो आपको मिलेगा, बट दैट डज नॉट मेक that does not assure you that this roll number is correct. ये आपको याद रखना पड़ेगा कि what value I have stored inside the union. Okay. Fine. Now Yusuf is asking, can we write a static variable in union? Well, this is something like I never have tried. Let's go for it, Yusuf. Whether it allows us to have a static variable inside a inside not a structure. Even it does not allow you to define it in structure. Let's have a look at that thing. Yeah, and let me try to compile this program. Well, it is not allowed, right? Type name does not allow storage class to be specified static. So inside structure as well as union, you cannot have a static member. Okay, now it makes sense. It makes sense now. Look, you can have a static variable so that it can have a common memory allocation. Now this roll number and name, these two are not variables, these two are members, okay? And members cannot be static. So Yusuf, we cannot declare members as a static. Yes, you can declare static U1 and static S1 if you want. So your variable can be static. We can have a variable like struct student S and S2. This is a variable. Now we can have maybe a static variable here, right? So static variable of a structure student S type and variable name is S2. So this is possible. And similarly, you can have a union also. Union, you can have U2 variable. So your variables can be static. So both these statements are valid, and there is no problem if I compile if I run this code. No errors there, right? Yeah. So that's all about structures and unions. Now, any more queries or other doubts here? Okay, Tushar is asking how this roll number come. So I believe you are asking about this union roll number, right, Tushar? Look, when you have a common memory, then on the same place you have stored this Marwadi, okay? And when we try to access this u1.roll, it tries to access those 4 bytes from the memory. Now, let us have a look at that on pen and paper. Let me explain that thing here. So we were having a union of student, and inside that we were having integer roll, and we were having a character name of 20 size, and we were having u1 variable. So as we discussed already, what happens when we look at the memory, we will have total 20 bytes of memory allocated to us, labeled with u1. So this is going to be of 20 byte size, and your u1.roll as well as u1.name both will be pointing to the same memory location, correct? Because both members are going to share the same memory, and inside that these are the 20 bytes. So maybe see 0 1 2 3 4 5, or rather let me have clear byte separation. It's kind of an array. Up to 19, correct? So this is your memory allocation. Now what happens is, let me copy this much part because we want to work on the same thing again. Okay, so this is our memory allocation. When I assign roll number equals to 12, what it will do, integer requires 2 bytes or 4 bytes depending on the operating system. Okay, let us understand it requires 2 bytes. So it is going to store that value 12 at this place. Okay, at this place it is going to store that 12. 2 bytes, so 12 will be converted to binary, and that binary data is going to be stored inside the memory. Okay, so that's how you store 12 inside this memory. But later when you assign Marwadi here, then what it is going to do is it is going to use the same memory allocated to you, and it does require 7. It has a 7 characters, so it requires 7 bytes inside your memory. Okay, so what this will do, it will overwrite your roll number. It will occupy, or it is going to use this much size of your memory. So it is going to overwrite this 12. First character will be M, then A, R, W, A, D, I. That's how it will store Marwadi inside. Now this is how your data is being stored in the memory. Now presently you have Marwadi stored inside the memory location. So when you access u1 dot name. When you access this, it is going to access size of name is total 7 characters. So 7 character. It is going to fetch from the memory. So it is going to read 7 bytes from the memory. It is going to read 7 bytes from the memory, and that will give you correct word Marwari, right? But when you access u1 dot roll, now roll number is the integer value which requires 2 bytes. So it is going to read those 2 bytes MA. It is going to read the data MA. Now actually it is not MA. You all know that characters are internally considered as a ASCII value, and ASCII values are stored in the memory by converting it to binary data, because at the end inside your memory everything is binary. Computer understands binary, so it works with binary. So this MA character ASCII values will be converted to some binary data, and those binary data, total 2 bytes data, then will be converted to integer value. Will be then converted to integer value because we are printing it in %d format. So whatever output you have on the output screen, right, it's something like 200-398-4717, and this is actually 2 byte read from the memory location and converted it to integer. Now not exactly 2 bytes, in my system it is going to be 4 bytes. So it have read 4 bytes. So for this actual output it has gone for MARW, its binary equivalent converted to integer value. So this is what you have as an output. Okay. So I hope, Tushar, I have made your doubt clear. So means it change every time if we change name. Yes, obviously you are using the same memory location, so it will be changed every time. If you change your name, then roll number will be changed, because the memory location will have a different value now. Fine. So this you have to understand clearly. Inside a union, all the members are going to share the same memory location. So whatever is the last value stored inside union will be going to be preserved. If you access any other member, then that member will have some data but not actual data. If you access integer member, then it will read 2 bytes. Fine, but those 2 bytes will not be the actual integer value. Yeah, any more doubts or questions? Okay then, so well, it's only 5 minutes left, so we'll conclude this session here, where we have completed our 8th unit, which is based on structure, and we have also covered union simultaneously along with the structure. In next week, starting from next session, we are going to start a new unit number 9, which is dynamic memory allocation. So if runtime you want to allocate a memory, then how can we do that thing? We are going to look at few inbuilt functions of dynamic memory allocation. It's malloc, calloc, realloc, and to make that memory free, we have a free function also. So we'll see dynamic memory allocation in the starting from the next lecture. Okay, that will be the 9th unit. We have 2 more units to see: dynamic memory allocation, and then the file structure, file handling. And I believe we have enough time to cover those 2 units now. Okay, so that's all from my side today. Thank you all for being part of this session here, and see you in the next session on Monday. Bye bye.